The facade assembly options presented in this course provide a great opportunity to talk about windows, doors, balconies, and ventilation outlets. In all three options where the precast concrete is the performance facade, windows are placed within the triangular or diamond-shaped apertures of the precast concrete screen. For obvious reasons, placing openable windows within non-orthogonal apertures is a challenge, as it will require bespoke ironmongery. For this reason, we have opted for non-openable windows in the diamond-shaped apertures, with the top part of the aperture designed for the ventilation outlet with louvers. The duct for the ventilation outlet can be located in the void behind the ceiling. If the building is only mechanically ventilated, there shouldn't be any further requirement for openable vents in the facade, and the triangular apertures could be closed off with aluminum panels. However, if there is a requirement for natural ventilation of internal spaces, or for fire safety reasons, the triangular apertures could be utilized for this purpose. The aperture could be filled with a window profile screen. Horizontal transoms and vertical mullions could be introduced to the screen to form a rectangular inward opening vent. Now the window can utilize standard, tested and certified off-the-shelf hinges and handles. This improves the route to compliance and keeps the cost low. In our visualization, we show insulated glazing units glazed in the window profiles. However, insulated aluminum panels could be used in this instance. To conceal the profiles of the window, horizontal louvers are installed on the outside of triangular aperture. The openable window is located below 1100 mm from the functional floor level, or FFL. There should be a provision for a restrictor, which would prevent the window from being fully open. However, if the louvers are proven to be suitable to act as a barrier, the restrictor to the window may not be required. Having said that, it is best to make provision for the restrictor, at least at the initial design stages. Most of the hotels have restrictors installed on the windows, even if the vents are above 1100 mm level. The design option with the stick curtain wall acting as the performance facade relies on the balcony to act as a buffer zone between curtain wall and the precast concrete screen. Since the balcony stretches around the perimeter of the facade, it is definitely larger than 6 square meters. That means that it has to be positively drained, indicating that the rainwater is brought back towards the building and discharged through rainwater pipes, commonly referred to as RWPs. In our case, we have opted for the aluminum decking system, which directs rainwater through the channels between the extruded aluminum decking planks to the gutter located at the edges of the balcony. The outlet, with an overflow mechanism, directs the water through the horizontal pipe located between the soffit and the decking to the rainwater pipe located next to the curtain wall's facade. Balcony decking is installed flush with the floor threshold and slanted towards the balcony edge. The internal floor finish, coupled with the decking level, allows the balcony to be accessible via wheelchair. The maximum size of the threshold is 15 mm in cases when the balcony is to be accessible. The height of the balustrade should be no less than 1100 mm from the decking. The gap between the balusters should be no less than 100 mm. The materiality of the balustrade will be discussed in more detail in the fire safety tutorial of this course. The plenum spigot connection should allow for drainage of moisture resulting from condensation. The bottom part of the plenum should be designed with a slight fall to prevent water from ponding in this location. The timber structure will move due to life load deflection and timber shrinkage. Hence, fixing the privacy screen to both curtain wall and the precast concrete screen should be avoided. Privacy screens are likely to be fixed to the balcony at the bottom and to the balustrade on the side. The interface between balconies and the primary frame is a high-risk detail, especially if the primary framework is mass timber. It is crucial to seal the penetration of the bracket through the insulated spandrel panel of the curtain wall. The installation sequence is likely to be like this. Firstly, the balcony stub is installed to the edge of the cross-laminated timber slab. At the same time, curtain wall brackets are installed to the edge of the slab, and the aperture is formed with mullions and transoms around the balcony stub. An insulated aluminum spandrel panel is installed in place and secured to the profiles with pressure plates. There is a hole in the panel to allow for the balcony stub bracket to protrude through the curtain wall facade. The aperture should be large enough to allow for movement of the primary framework in relation to the facade. The resultant void should be filled with mineral wool insulation. The balcony stub is expected to be constructed from hot-rolled box section, providing a more straightforward and durable solution for the application of weather seal membrane, specifically designed for this interface. Installing flashing beneath the cover cap of the transom above the balcony stub can serve as an extra precautionary step functioning as an additional safeguard to channel rainwater away from the interface protected by the weatherproofing membrane. To shield the concrete panel beneath the window from staining, one should install an aluminium sill pressing. However, in the case of the Welbeck Street car park, stains are already present due to the building's unchanged existence for the past 50 years. Nonetheless, for new build structures, this preventative measure is recommended as a best practice detail. To deter pigeons from roosting, the installation of pigeon protection wires on horizontal ledges should be considered. While there are numerous facade components we could discuss, the scope of this brief case study course is limited. We cannot explore every facet of facade parts in detail here. For those interested in delving deeper into further aspects of windows and doors, their classifications of air and weather tightness, and other critical considerations for sills, copings, and various elements of facade assemblies, we encourage you to enroll in the Applied Facade Engineering course.